Let's try to understand the speed time graph. So let's say you've got two cars, car A and car B. Car A is traveling at a constant speed of 7. Car B is accelerating. So it's slow at first and then it speeds up and it speeds up. So the time graph, the speed time graph for car A would be, well, 1 second later the speed would be 7. So when it's 1, it would be 7. Another second later, when time equals 2 seconds, the speed will be 7. 3 seconds, the speed will be 7. The speed, because it's a constant speed, the speed is always 7. So your speed time graph for car A would look like this, where the height is always 7. So the formula is speed equals 7. That's the equation of this graph. S equals 7. Now for car B, it's accelerating. So acceleration means the speed increases every second. So here, when t equals 1, the speed will be 2. When t equals 2, the speed will be 4. When time is 3, hang on, let's start again here. When time is 1, the speed will be 2. When time is 2, the speed will be 4. When time is 3, the speed would be 6. When time is 4, the speed would be 8. So your time graph will look like, your speed time graph will look like this for car B. You can see that the speed is increasing. Well, what's the equation of this line? Well, any straight line would be y equals mx plus c. We can see that the intercept is 0. So put 0 into the c. So that really plus 0 means nothing. You can just ignore it. What's the gradient of this line? Well, if you draw a triangle underneath that line, you can work out the gradient. The gradient would be the height divided by the across. Well, the height is 2 because it climbs by 2 each time. Acceleration of 2 means it's going to climb by 2. So the height will be 2, the across is 1, so the gradient is 2 over 1, which is 2. So the equation of this line is y equals 2x. When you translate it, the y-axis represents speed, and the x-axis represents time. So the equation is speed equals 2t. Now, if you want to know the distance traveled, it's actually the area underneath. The area underneath the speed time graph represents the distance traveled. Because if you look at this car, 1 second it has traveled 7 meters. Another second it would have traveled 7 meters. It's always traveling at 7. Look. 7 meters, the area is 7. This area here is 7. This area here is 7. So if you want to know the distance traveled, work out the area underneath the speed time graph. So let's say you want to know at time t, then you would get 7 times t. So the distance is 7t. So it's just the area underneath there. When you have an acceleration, it becomes slightly more complicated. It is the area underneath the speed time graph. So in our case, if you want to know the distance traveled after t seconds, work out the area underneath there. It would, well, at time t, what's this height? Well, you would put it into here. It would be 2t. The height would be 2t. This distance here would be t because it's t across. So what's the area? The area would be this times this, which will be so it would be this times this. So distance equals this times this. So that would be t times 2t. So that will be 2t squared. That will then give you a rectangle, and then you cut in half to get the triangle cut in half. These two cancel each other out, giving you t equal d. Distance traveled is t squared. So for an acceleration of 2, all you need to do is square the time, and it will give you the distance traveled. The moral of this video is that if you want to know the distance traveled, work out the area underneath this speed time graph. Work out the area underneath the speed time graph. Okay?